I'm Anil Kumar sharing with you some concepts about reciprocal and rational functions which have evolved as a result of my discussion with my student Gurmeet. Gurmeet, thanks a lot for asking some brilliant questions which led to this particular video, and I hope many students will appreciate it. So we'll basically talk about two questions which evolved from our discussion. The first question here is, which of the following statements is true? Reciprocal functions are also rational functions. B. Rational functions are also reciprocal functions. C. 2 over x plus 3 is a reciprocal function. D. All the above are true. E. All the above are not true. So we have these five statements here. Now the other question which evolved here is this particular question, which I am going to discuss in the video. That is, why did we study reciprocal functions as a part of rational functions if they are not rational functions? Well, simple but difficult question to answer. So let's begin with understanding what is reciprocal function first, right? So let me write reciprocal function. So in general, we say reciprocal function is 1 over f of x, right? Where f of x is any function, right? We can also limit f of x to something but not 0, but any function. Okay. Now when we say rational function, what do we mean? So rational function is basically equal to some polynomial over another polynomial, where of course the denominator is not equal to 0. However, both polynomials n of x and d of x are only polynomials. Perfect. So that is easy to understand. Reciprocal functions are also rational functions. It is definitely not correct, since we could have a reciprocal function as 1 over sine x, for example. Sine x is not a polynomial. We could have 1 over log x, for example. We could have something over e to the power of x plus 1, for example. Now all these functions are not polynomial functions. However, they could be considered reciprocal functions, right? So 1 over. So they do confine to the definition 1 over f of x. Correct? So this statement is not true. Correct? So we have the first statement which is wrong, not true. Second, rational functions are also reciprocal functions. Now, here what we say is that for simplicity, we think numerator as a constant for reciprocal function. Well, there are no restrictions, but in general, 1 over, I could replace this with k over, for example, right? So we could think about f of x as a transformed function, right? So in that case, it could be k over something, right? So we say this is also not true. C, 2 over x plus 3 is a reciprocal function. Now we treat this as true. Now what do we see x plus 3 as? Now the function here basically is half of x plus 3. It's linear. Do you see that part? So if you treat this as simple function half of x plus 3, it becomes reciprocal of this. So here we are saying reciprocal function is 1 over half of x plus 3. Does it make sense to you? So we'll say this is the correct statement. This is the correct statement, right? So all of the above statements are true. First two are not true. And we say all of the above statements are not true. Well, that is also not true since C is true. So I hope that makes things simpler to understand, right? So if there is a constant here, something like this, you can say a transformed parent function. Perfect. Now you can see very easily that reciprocal functions could have reciprocal of any function other than polynomials also. And that is why they are all not rational functions. So I hope this point is clear. Now let me take the second question, and which is a very valid question. Why did we study reciprocal functions as a part of rational functions if they are not rational functions, right? It makes sense. So the idea here is to start with simple things, right? So I should say it is because of their simplicity. So at times we do see that simplicity leads to complexity. So that is always there. But it helps us to really solve complex problems also. So that's the whole idea. So there are two ways to look into it. First part, when we look into reciprocal functions, is concept, which is one, I should say, algebraic concept. That reciprocal function r of x is equal to 1 over f of x, where f of x is not equal to 0. So that is the algebraic concept, right? The other concept is about the characteristics. Now, here are a few important things which we have learned about the reciprocal functions. That is, let's make two columns to really get into it. Let's think about characteristics like, for example, if we have a function f of x and we have 1 over f of x, in that case, if f of x is positive, then 1 over f of x is also positive. If f of x is negative, 1 over f of x is also negative. If f of x approaches infinitely large value, then 1 over f of x approaches 0. Correct? When f of x approaches negative infinitely large value, then 1 over f of x approaches again 0, but from the negative side. You get the idea. So in the first case, it approaches from the positive side. Right? So this basically gives you the concept of end behavior. And we also look into horizontal asymptote. For reciprocal functions, right? So it gives you a concept of horizontal asymptote. That is very important. Now the other part which we also learned is that f of x cannot be 0, but it can approach 0. So if f of x approaches 0, then 1 over f of x approaches infinitely large value. Right? So it all depends whether you are approaching 0 from positive side or negative side. So, but f of x approaches negative large value, very large value. Now, here again, we understand the concept of vertical asymptote. So these are major characteristics which we could appreciate with very simple reciprocal functions. And that's kind of introduction to some complex behavior of rational functions, right? So characteristics like you have seen here, end behavior, let me write asymptotes, and restrictions, can be studied with reciprocal functions. Easy to understand. With reciprocal functions. So that is the base. And this will first apply to rational functions, and then we could apply to other functions also. Do you understand? So this base could be applied to rational functions and then to others. So the first unit which you learn after reciprocal is rational functions, and then you're going to apply the same concepts to reciprocal of sine function, reciprocal of logarithmic functions, reciprocal of other functions. I hope that makes sense now, right? So once again, thanks a lot, Gurmeet. That also gives me an opportunity to explain the topic in more details. And I hope many of my subscribers and viewers also benefited. Thank you.